Have you ever launched a game and marveled at its realistic graphics, smooth character movements, or intelligent enemies? Behind all the visual spectacle and engaging gameplay lies a hidden world of mathematics. From the physics that govern how objects move to the algorithms that control artificial intelligence, math is the invisible force that powers our favorite video games. While we're busy battling dragons or racing cars, complex mathematical equations are being crunched behind the scenes, translating lines of code into the immersive experiences we enjoy. This essay will take you on a journey to uncover the crucial role of mathematics in video game development. We'll explore how different branches of math, from geometry and algebra to calculus and statistics, come together to create the games we love. So, the next time you boot up your console or PC, remember that you're not just playing a game, you're interacting with a complex and fascinating world built on the foundations of mathematics. Get ready to see your favorite games in a whole new light as we dive into the fascinating intersection of math and gaming. One of the most noticeable ways math impacts games is through physics. Game developers use physics engines to simulate how objects move and interact in a realistic way. These engines rely heavily on Newtonian mechanics, a branch of physics that describes the relationship between an object's motion and the forces acting upon it. Remember playing a racing game and feeling the car's weight shift as you take a sharp turn? Or the satisfying thud when you land a jump in a platformer? That's the magic of physics engines at work, using math to calculate forces like gravity, friction, and momentum to determine how objects should move and behave. Without physics engines, games would feel lifeless and artificial. Objects would move in unrealistic ways, and the sense of immersion would be broken. Thanks to math, game developers can create games that feel believable and responsive, blurring the lines between the virtual and real world. Moving beyond the physics of individual objects, math also plays a crucial role in crafting the very environments we explore in games. 3D graphics, a cornerstone of modern gaming, rely heavily on linear algebra and geometry. Game worlds are constructed using polygons, essentially shapes like triangles and squares, which are positioned and manipulated using matrices, a fundamental concept in linear algebra. When you marvel at the breathtaking landscapes in an open-world game or the intricate details of a character model, you are witnessing the power of linear algebra and geometry in action. These mathematical tools allow developers to create complex and visually stunning 3D environments that feel real and immersive. But it's not just about creating static environments. Math also helps breathe life into these worlds. Lighting and shadow effects, crucial for creating realistic and visually appealing graphics, are achieved through complex calculations involving vectors and trigonometry. The way light bounces off surfaces, casts shadows, and interacts with different materials is all dictated by mathematical equations. Have you ever wondered how games create a sense of unpredictability? Whether it's the randomized loot drops in an RPG or the challenging AI opponents in a strategy game, math plays a crucial role in making games feel less predictable and more engaging. Probability and statistics are essential tools for game developers when designing game mechanics like loot boxes, item drops, and critical hit chances. By carefully adjusting probabilities, developers can control the rarity of items, the frequency of events, and the overall balance of the game. This ensures that players are kept engaged and rewarded for their efforts, without making the game too easy or too frustrating. On the AI front, algorithms like A*, pronounced A*, come into play. This algorithm helps AI characters navigate complex environments and find the optimal path to their goal. Whether it's an enemy chasing the player or a non-player character navigating a crowded city, A** allows AI to make intelligent decisions and interact with the game world in a believable way. Without these algorithms, AI characters would feel robotic and predictable, diminishing the challenge and enjoyment of the game.